We shall move to the next question. Question number 42. Question number 41 is a simple question. You can do it by yourself. Question 42. Let us read the question once. Water is flowing through a taper pipe of length 100 meter, having diameter 600 mm at upper end and 300 mm at lower end. The rate of flow is 50 liters per second. Pipe has a slope of 1 in 30. Find the pressure at the lower end if the pressure at higher level is 19.62 Newton per centimeter square. So we have been asked to find out the pressure at the lower end if the pressure at higher level is 19.62 Newton per centimeter square. 19.60 Newton per centimeter square. From reading the problem, we can understand that pipe is a tapering one because it is having two different diameters at two different points. At top, it is having 600 mm, and at lower end, it is having 300 mm. And also, it is having a slope of 1 in 30. That means the pipe is a tapering one and an inclined one. We have been provided with P1. We need to find out P2. We need to find out P2. P1 is given. We need to find out P2. Now let us write the Bernoulli's equation first, because whenever you see terms like pressure or discharge velocity or datum, all these things, if you have been asked to find out all these things, you will have to use Bernoulli's principle. So let us write the Bernoulli's principle. Simply let's write Bernoulli's principle. P1 by rho g plus V1 square by 2g plus Z1 will be equal to P2 by rho g plus V2 square by 2g plus Z2. Now let us see all. Let us mark all the given data. Let us take P1 as, or all the 1 terms as of higher level. 1 be the higher level. In the question they have said it is higher level and lower level, or upper end and lower end. 2 as lower end. P1 is given as 19.60 Newton per centimeter square. V1 square by 2g we can find it out from the discharge 50 liters per second. We can find it out from that. Z1 is not given. P2 by rho g we need to find out. P2 by rho g is something that we need to find out. V2 square by 2g can be found out from discharge, and Z2 is also not given. So we have arrived at a situation that we have to find out P2 by rho g, Z2 and Z1. Also, there are 3 unknowns for us, Z1 and Z2. Now, here in the question they have said that the slope is 1 in 30. Since we have been stuck with 3 unknowns, and especially we don't have a value for Z1 and Z2, what you have to do is that you have to take one section passing through the datum line. Like one section is passing through the datum line. If you draw it like that, you can make Z1 or Z2 0. So how you have to position the datum line is like that. You have to position the datum line such that the datum is passing through either the section 1 or through section 2. By doing that, you can make Z1 or Z2 0. If you can make Z1 or Z2 0, you will have just 2 unknowns. You can easily solve that. So if in a problem we have been not provided with Z1 or Z2, or we are not provided, or we don't have a way to find out Z1 or Z2, what you have to do is that you have to position the datum line in such a way that Z1 or Z2 becomes 0. And how to do that? You have to position the datum line at that section. So let us draw the figure and you will understand it. So this is our pipe. And the pipe is 100 meter length, diameter 600 mm at upper end. So this is 600 mm. This is the 600 mm, and this is the 300 mm. This is our pipe. Now if you position datum like this, value of z1 is unknown and value of z2 is also unknown. So if you position datum like this, you will be stuck. You will get stuck. You can't move forward. So what you have to do is that you position the datum like this. By doing like that, the z1 will be z2 will become 0. That is because we have taken 2 as 2 related to the lower part. So z2 will become 0. And the inclination is given it as slope is 1 in 30. So that's how you have to do it. Now let us write the P1, P2, V1, V2, Z1, Z2 terms. So this is section 2 and this is section 1. Because we have considered 1 at higher level. Let us start doing. P1 equal to 19.62 Newton per centimeter square, that is 19.62 into 10 raised to 4 Newton per meter square. V1 equal to discharge by A1 Q by A. V1 equal to Q by A1, that is Q equal to 50 liters per second, so that is 50 liters per second, that becomes 50 divided by 1000, 0.05 meter cube per second divided by pi into 0.3 square by 4. Therefore V1 will be 0.177 meters per second. The Z1 will be, we have to find out Z1. This value we need to find out. Now what can we do? We can do, this is 100 meters. This is 100 meters. Because that's something that we've been given in the question. Length of the pipe is given as 100 meters. Now we will have to find out Z1. For that, let us take the slope in 130, that point. So this will be 1, this will be 30. 130 means 1 vertical to 30 horizontal, and this angle will be tan inverse of 1 by 30. That is equal to 1.09 degrees, something like that. Okay. So we got this angle. From this angle we can find out Z1. Z1 will be equal to sine 1.09 will be equal to Z1 by 100. Therefore Z1 will be equal to sine 1.09 times 100, it is 3.33 meters. So we got the value of Z1 also. Now we can find out V2. V2, which will be equal to Q by A2. That will be equal to Q by A2 be equal to 0.707 meters per second, and Z2 will be equal to 0. Since the datum is passing through the section itself, Z2 will be 0, and P2 we have to find out. So by using the Bernoulli's principle, you will get P2 is equal to 228,573 Newton per meter square. 228,573 Newton per meter square. So from this problem, one thing you have to understand: if the value of z1 and z2 are not directly given, and if there is no hint in finding out z1 and z2, no easy way to find out z1 and z2, what you have to do is that you have to position the datum in such a way that at least z1 or z2 becomes 0. So that is the turning point, or that is the pivotal point in solving these kind of